If you're torn between BM25 and embeddings, you don't have to choose. RRF is a simple way to combine rankers and often improves top results immediately. Let's implement and compare. Maybe your search returns exact phrase hits but misses meaning. Or your embedding search finds related concepts but ranks odd pages first. I'll show a small practical fusion that gives you better top results without heavy infrastructure. You will learn the idea, build a tiny Python baseline, and see how one parameter controls how much each ranker influences the answer. I'm Professor Pi, teaching search and IR from basics to advanced with simple concepts-first Python that helps you solve bigger, real-world problems. Reciprocal Rank Fusion solves a common problem in search engineering. You have two rankers that each do something useful. One favors exact term matches. The other captures synonyms and inflection. Individually, they miss different relevant items. Fusion takes advantages from both and often improves the first page of results. The main constraint is that Fusion works on ranks, not raw scores, so it does not learn new features. It is simple, fast, and robust when you need a quick hybrid baseline. The intuitive idea is easy. Imagine two ordered lists from two rankers. Each position gets a small reward. Items that appear high in either list collect more reward. The reward is reciprocal of rank plus a constant. That makes top positions matter more. If a document is top for either ranker, it tends to rise in the fused list. Strengths are simplicity and no score calibration. Weaknesses include limited modeling power compared to learned rankers and sensitivity to the chosen decay constant. We will build a tiny lexical ranker, a tiny semantic ranker, a fuse function that implements reciprocal rank fusion, then a small routine to test different decay values. You will see how fused top 3 results change for a single query. This snippet builds a tiny lexical ranker to show exact term matching behavior. We create a short list of documents and a query, then map each document to an index for later reuse. The function lex sorts document indices by how many query tokens appear in each document, using simple token counts as the score. We convert the top indices back to document strings so the result is readable at a glance. This basic baseline mirrors BM25's preference for exact tokens without any synonym handling. The printed top 3 shows how lexical ranking favors exact matches and overlooks close variants like barkin. In practice, this lexical ranker demonstrates why exact matching is fast and predictable. It rewards shared tokens and punishes vocabulary gaps. That makes it strong on formal queries or exact phrase lookups. But you will see it miss words like canine or puppy when the query contains dog. This gap motivates adding a second ranker that collapses synonyms so we can compare and then fuse. Now we will add a simple semantic ranker that normalizes related words. This snippet adds a simple semantic ranker that normalizes synonyms and inflections. The dictionary syn collapses words like canine and puppy to dog, and barks or barking to bark. The function n applies this mapping and light suffix stripping, so related words line up. The sem ranker counts normalized token overlaps between the query and each document, then sorts by that score. This approximates an embedding model's strength on semantic similarity without heavy dependencies. The top 3 now pulls in puppy barking, revealing how semantic matching rescues meaning missed by pure lexical scoring. This example shows how normalization recovers meaning. By mapping related surface forms to a canonical token, we simulate semantic generalization. It is not as rich as vector embeddings, but it highlights why combining rankers helps. When the semantic ranker elevates different documents than the lexical ranker, Fusion has room to improve the set of top candidates. Next, we will implement Reciprocal Rank Fusion to combine the two lists. This snippet fuses lexical and semantic rankings with Reciprocal Rank Fusion. The variable k controls how quickly contributions decay with lower positions. The function fuse takes two full ranked lists of document indices and sums 1 divided by k plus rank for each document, then sorts by the combined score. We create a rank from the lexical ranker and rank from the semantic ranker, then compute a fuse top 3. RRF is robust because it rewards items that appear high in either list without needing spore calibration. The fused output blends strengths from both rankers, improving coverage of releva. This code block clarifies why RRF is tolerant of different score scales. Lexical and semantic rankers often produce incomparable scores. RRF only needs orderings and uses a reciprocal weighting to produce a combined relevant score. The parameter k is the lever you will tune when you care more about agreement at the top or more about broad coverage deeper in the lists. Now we will inspect how changing the k parameter shifts emphasis in the fused ranking. This snippet shows how the RRF parameter k shifts emphasis on top ranks. We compute fuse results with a small k of 10 that heavily rewards early positions and a large k of 200 that spreads weight more evenly down the lists. Both runs reuse the same lexical and semantic orderings, only changing how quickly the reciprocal contribution decays. Smaller k amplifies agreement at the very top. Larger k is more forgiving and can reduce sensitivity to minor rank flips. The printed pair compares the top 1 choices across k settings, so you can judge stability. You can use this comparison to pick a k that matches your product goals. Choose a small k if you want the absolute top results to be very stable and driven by strong agreement. Choose a larger k if you want a more diverse fused list and less sensitivity to single rank differences. Runtime cost is negligible since you only sum reciprocal values across candidate lists. Finally, we will wrap these pieces into a reusable search function that runs both rankers and fuses results. This snippet wraps the pieces into a tiny fused search function. The function search takes a query, gets lexical and semantic rankings, applies RRF with k, and returns the top 3 documents. It composes the earlier lex, sem, and fuse primitives so you can reuse it across queries without rewriting logic. Using the query k9bork, it recovers both exact and synonym matches, illustrating a robust hybrid baseline. Lower k will favor the first positions in each list more. Higher k will smooth differences. The printed top 3 shows a practical fused retrieval result you can build on. With a simple search function, you can iterate on tuning and on corpus size. It also becomes easy to plug in a real BM25 implementation and a vector model later, while keeping the same fusion logic. Recap. What it is: Reciprocal Rank Fusion sums reciprocal rank contributions to combine rankings without score calibration. When to use it? Use it when you have complementary rankers like BM25 and embeddings, and you need a quick hybrid that improves top results. One caveat: it cannot learn complex interactions and depends on the chosen decay constant. Wrap, punch. Next step: scale this exact pipeline by swapping the lexical baseline for a production BM25 and the semantic approximator for a small embedding index. Then evaluate top K accuracy as you sweep the K parameter. If short practical IR helps, subscribe and watch the IR videos.